everyone. So we're going to continue our talks about factoring and breaking up these polynomials. In particular, we're going to focus on factoring trinomials. So the way we're going to do trinomials, remember these are polynomials that have three terms. So something like this, 2x squared plus 3x minus 7, or 8x squared minus 4xy plus 3y squared. Those are all trinomials. They are three terms. And then the method that we're going to be using is specifically going to be on the trinomials where that leading term, remember when we write in standard form, that the leading term is going to have a coefficient of 1 and a power of 2. So something like this, x squared plus 3x minus 7, or x squared minus 4x plus 3. For example, something that had x to the cubed would not be considered one of the methods we're going to be looking at, though we will actually look at a few where this won't be the case. So the method that we're going to be using for these trinomials is the addition multiplication method, or sometimes called the AN method. The way it's going to work is that we're going to find two numbers that either add to the middle term and at the same time multiply to the last term. So what we're going to end up doing is we're going to look at those two terms, the middle term and the last term. We're going to find all the factors that lead to that last term and all the factors or the parts that can add up to the middle term, and whichever one matches, that's our answer. Those two numbers will then be written as factors like this. So if we have something where the variable is x and that's our trinomial, it'll be written like x plus blank times x plus blank, where in these blanks would be the two numbers that we found that multiplied to the last term and added to the middle term. All right, so just for a quick example to see what I mean by that. So here we have a trinomial. It has a leading coefficient of 1 and a power of 2. There's three terms. 9 is the last term and 6 is our middle term. So we need a number that's going to add up to 6. So these are three sets of numbers: 1 and 5, 2 and 4, 3 and 3. Then we also have to find numbers that multiply to 9: 1 and 9, 3 and 3. There's only one combination, which is the 3 and 3, that is in both. So our factor, or the way that we're going to factor this, is going to be written as x plus 3 times x plus 3. And we can double check by expanding this out to see if we get our original example. Now, I started here with the addition part, but it's probably better to start with the multiplication part, since there's usually going to be a lot less factors for that, and then seeing which of these will actually add up to the middle term. Be careful though of negatives that are in here, because you're going to have to include that. For example, if this was negative 9, 6x minus 9, then the multiplication could be 1 and negative 9, or 9 and negative 1. So keep that in mind, pay attention to the negatives, but this is what you're going to end up doing. Find the factors for that last term, see which one adds up to that middle term, and there you go. All right, so pause the video, work on itself, and we'll go over in a second. All right, so we have our trinomial written in standard form the way it's supposed to. We have to find numbers that will add to 15 and multiply to 50. So starting off, if I write factors of 50, it's 1 and 50, 2 and 25, 5 and 10. Then I believe that's it. Yeah, I think that's all the factors for 50. Let me just double check. Yeah. So, yeah. Now we have to see which ones add to 15. So if we had 50 plus 1, this will add up to 51. This adds up to 27. This one adds up to 15. So 5 and 10 are my numbers. So I'm going to write x plus 5 and x plus 10. All right. For this one, we're we're going to actually, it's going to be slightly changed because now instead of x, we're going to have a's, but besides that, everything else stays the same. It's now going to add to negative 11 and multiply to 18. Now, here's the thing, because of the fact that this is positive and this is negative, that means these numbers that are multiplying to 18 are going to have to be negative numbers, because positive plus a positive number will always give you another positive. So the numbers that we're going to use would be negative 1 and negative 18, negative 2 and negative 9, negative 6 and negative 3, and that I believe is it. All right, so here we go. Once again, which ones add up to negative 11? This will get me negative 19. This will get me negative 11. And this gets me negative 9. So negative 2 and negative 9 are my answer. So I'm going to write this as a minus 2 and a minus 9. And there we go. Again, we can double check by expanding this out and simplifying it, but we'll find that we get this, what we got before. All right, here's the next questions. Pause video work itself. We'll go over in a second. All right, so now we're looking for a number that's going to multiply to or add to negative 5 and multiply to negative 24. Now, this one's going to take a little bit more time because both of the numbers are not going to be negative or positive together. So I'm going to have to write 1 and negative 24, but then I'm also going to have to include negative 1 and positive 24, since these are two different numbers that sets of numbers that will multiply to negative 24. Then we end up having, let's see, 2 and negative 12, negative 2 and positive 12. We could have 3 and negative 8, negative 3 and positive 8, 4 and negative 6, negative 4 and positive 6. So going through all these, we can see that this adds up to negative 23, positive 23, negative 10, positive 10. Start to see a pattern here. This is going to be negative 5, positive 5, negative 2, positive 2. So that means these are the numbers that I'm going to use. So my factor will end up being y minus 8, y plus 3. All right, down to here, we're looking for numbers that are going to add up to 6 and multiply to negative 7. So again, we could have 1 and minus 7, negative 1 and positive 7, and that's it. So adding these up, this can add up to negative 6, this adds up to positive 6. So these are the numbers I'm using. So it's going to be j minus 1, j plus 7. When you do a few of these practices, you'll notice a bunch of things. For example, whatever if this middle term is positive, then that usually means that the biggest term is also going to be positive. If it's negative, it means the bigger term is going to be negative. So this kind of helps out that you won't have to deal with, you can kind of cut up this in half and just worry about the ones where the negative number is the bigger one. All right, here's the next set. Pause video, work on itself, and we'll go over in a second. All right, so it has to add to negative 4, multiply to negative 45. Because this is a negative number, I'm only going to look at the ones where the bigger term is negative. So looking at the numbers, there's 5 and negative 9. Then there's going to be 3 and negative 15, 1 and negative 45, and I believe that's it. So adding these up, this ends up being negative 44. This will end up getting you negative 12, and this is negative 4. So this is the one we're using. That means my factor is going to be a plus 5 and a minus 9. For this one, they're going to add up to 9 and multiply to negative 22. So using my same pattern, the bigger number is actually going to be positive this time. So it's going to be negative 1 and 22 are one set of factors. Then there's 2 and negative 2 and positive 11. And that's it. So adding these up, this ends up getting you 21. This gets you 9. So my factors are going to be x minus 2, x plus 11. All right. Now let's look at a slightly more difficult case where there's not going to be a leading term of 1 and a coefficient of power of something other than 2. Now, again, we're going to look at the simpler cases like this, where all the numbers will end up being divisible by whatever the leading term is. And each term does have an x. So what we're going to end up having to do in a situation like this is, before we can do the AM method, we're going to have to do the greatest common factor, take that out to simplify the trinomial, and then we can do the AM method. So for example, here, each of these terms is divisible by 4. So our greatest common factor will end up being 4, and then each term has at minimum 1x. So if I do that, remove 4x, divide it out from each term, this trinomial turns into this. And then from here, I could do the AM method where I only focus on this part. Now later on, we'll see cases where we wouldn't be able to get away with this. So maybe instead of 4x cubed minus 12x squared minus 16x, it's 4x cubed minus 5x squared, in which case there is no greatest common factor. So we'll see a case like that later on, but for now, this is the one that we're going to do. You're going to do greatest common factor first, simplify it so that it looks like one of these basic trinomials, and then do the AM method. So here's the next one. Pause the video, work yourself. We'll go over in a second. All right. So our leading term can be pulled out from each term. So we can pull out a 5, and then at minimum there is 1s. So this is going to be 5s. If I divide a 5s from each term, I'm left with s squared plus 4s plus 3. So I'm looking for numbers that are going to multiply to 3 and add to 4. Because it's a prime number, the only factors are 1 and 3, and they add up to 4. So my factor is going to be 5s times s plus 1 times s plus 3. And again, you can double check this, make sure it fits, but that's how you would do it. Going to here, so again, I'm going to pull out the negative 3. That divides into all these evenly. And then I don't have to do anything else with the s's because the s's are fine. So then I'm left with s squared. Negative 15 divided by negative 3 is going to be a positive 5s. And plus 18 divided by negative 3 gets me negative 6. If you just want to double check, again, you can distribute and make sure that you get to this. So we're looking for numbers that are going to add to 5 and multiply to negative 6. So negative 1 and negative 6, negative 2 and negative 3. If they multiply to negative 6, it's got to be, and this is going to be positive. That means the bigger number has to be positive. So it's negative 1 and plus 6, negative 2 and plus 3. So from here, this is going to add to 5. This will add to 1. So my factor will end up being negative 3 s minus 1 times s plus 6. All right, here's the next question. Pause the video, work itself, and we'll go over in a second. All right, so again, I could divide that leading term out from each part. So the negative 2 gets pulled out. I'm left with an x squared here. 28 divided by negative 28 divided by negative 2 is going to be 14, positive 14. And 98 divided by 2 is going to be plus 49. So we're looking for numbers that add to 14, multiply to 49. The only numbers that go to here would be 1 and 7. 1 and 49, and then 7 and 7. This adds up to 50. This adds up to 14. So my factors will be negative 2, x plus 7 times x plus 7. Here I can pull out a 6b from each term. So divide this by 6b and I'm left with b squared. This ends up leaving me with 4b, and 126 divided by 6 is going to give me negative 21. So I'm looking for numbers that will add to negative 4 and multiply to negative 21. So my bigger number should be negative. So it's going to be 1 and 21, negative 21, 3 and negative 7, and that's it. These numbers will add up to negative 20 and negative 4. So 3 and 7 are my numbers. So I'm left with 6b times b plus 3, b minus 7. All right. And that's basically it. We're going to continue on with this factoring stuff. Here are the exit questions, so you can pause the video, answer these real quick. And like I said, if you have any questions with these, let me know. Message me on Remind, join Extra Help, do something like that so that I can kind of help you out. But it's just continuing on with the same stuff. Have a great day and good luck.